Hey everybody, and welcome back to Kerbal Space Program RP-0. This is our Twitch recap from last week, where we were showing off our new plans for our next generation of Mars surface installations. Now that we've got the reusable-ish crew lander thing down, we wanted to give them a base to inhabit and do some quality research. So our plan is actually to land it in multiple modules. The module you are looking at right now is the habitat core. This will probably be the first module that we land because, well, reasons that will become kind of obvious later on. It is a direct to Mars tile plan, and we have built an Aero shell for it, which is currently detached, that will handle most of the atmospheric part of the entry. There is the bottom part, the basket. It is detachable. It has its own engine that we will be using for capture at Mars, as well as the deorbit maneuver, thrusters for maintaining attitude control, etc. And then we have the top part of the shell, still detached, which does contain more thrusters and an initial drogue chute. The primary descent chutes will be attached to the surface base or the habitat module itself. And there it is, all closed up. Very nice. It did earn a nickname. Unfortunately, we're not going to be sharing that here, but we'll go ahead and get our staging checked out. We do want to do some landing tests on these rigs before we just go ahead and call it good enough. So we'll set ourselves a simulation at Mars, a starting orbit of 250 kilometers, and then realize that we don't have a connection. Now, because of the delicate nature of the deorbit and landing process, I really, really, really want to have direct control. Preferably without signal delay. Now, the advantage here is that we will have a crew on Harmonia Station of 6 Kerbals with a remote tech guidance unit. So as long as they have a line of sight with that, or a indirect line of sight bouncing through a satellite, we should have, a close enough approximation to direct control for landing of this thing. That we need to execute the very time-sensitive maneuvers required to pull off a successful landing. This simulation, however, is just a huge waste of money. With a 14-minute delay, it's not going to be very possible. So I would try to improvise by wedging in a remote tech direct guidance unit, and I thought I'd put 4 or 6 Kerbals on board just for the hell of it, which did require actually hiring 2 more Kerbals. So we'll hire Mikhail Vihyoden. I don't know how to pronounce that name correctly. And really, there was no names in this recent list that just stuck out to me. So Alan Elliott, most generic name we could possibly find. And we'll dump all 6 Kerbals in here now. The problem here is, in order for the remote tech guidance unit to work, there has to be a command-capable command pod, as well as 6 Kerbals on board. So, we got like 2 out of 3 requirements met. So still no direct control, and yet another botched, completely wasted simulation. So I was getting a little frustrated with this. I have done some testing with it off stream, and did have some mixed results. I would like to at least get one solid demonstrator on before we go ahead and call it qualifiable. So we'll just reset our changes here to the core module and move on to our next batch of testing, which I think is going to be either our lab crawler or our supply crawler. Well, it has to be one of those two. Those are the only other 2 modules that we have. So we will tuck the project M97 core off to the side for now. We will be doing more testing with that in upcoming episodes, so do not fret. There will be more of that to be seen. This is our lab crawler module, which I will probably have to show to you at a later time, but we will be landing at least one of these, hopefully somewhere near the base, and upon a successful landing, it will just drive itself to the habitat core and go ahead and perform docking. Now, because this has a command module on board that was the original root part, it actually bypasses remote tech, which is a little cheaty, but for the purposes of running this simulation, it actually works out really, really well for us. So we'll go ahead and make our deorbit burn. And I should point out also that the Aero shell used for both the lab and supply crawler and the station core are completely identical. I just made sub-assemblies out of them so that we could very quickly install them onto new parts, and hopefully we can use this for a whole lot of stuff for landing on Mars, although it's not the most mass efficient system, and really for anything massing less than like 25 tons, it's probably just not the way to go. But as far as getting heavy things down to the surface of Mars, I hope for this to become a very readily deployable, infinitely replicatable system. In Physics Warp, we do get the ever-present SAS bobble, which, yeah. When not in physical time warp, however, it is relatively stable, and we can actually hold about 50 degrees above horizon in our coast phase here in the upper atmosphere, which does really bring our vertical sink rate down. In testing on all three modules, I've been able to get it down to about 35 meters per second or so sink rate, which gives us a nice long flat sink through the atmosphere and plenty of time to slow down, which is absolutely wonderful, because that 1,340 meters per second you're seeing on your screen for our descent stage, we will not have access to even half of that for the actual landings, which was an oversight on my part when I started running these simulations, just to remove some of the fuel for orbital insertion that would not be used for aerobraking and targeting, because, well, we'd like to land these close to wherever the core lands, and I do hope to specifically target where the habitat core lands also, to the best of my very, very limited abilities. So as we get lower in the atmosphere, it does become a little bit more taxing to maintain that 50 degrees. We'll let it slide down to about 30, but our vertical sink rate did not get nearly as low as I would have liked it to, and as you can see, we're still moving at about 3.2 kilometers per second, which is well, it's pretty fast even for this altitude. So in an effort to just slow down, we'll go ahead and let that sink rate increase to get us into some denser, thicker air in the lower parts of the atmosphere, and go ahead and go broadside in so that we can create as much drag as we can. Now you can see that we are actually bleeding speed off at a rate of about a meter per second, which not the greatest rate of slowdown in the world, but it was not the only indiscrepancies we would see between my offline and off-stream testing of these devices and the simulations we're running on stream here today. But I'm actually going to let old me tell you about the latest bit of interesting things. It's around the fun part. Oh, whoa. What the hell just happened? Aerodynamic stresses. Are you kidding me? Don't you have to have, like, air pressure to have aerodynamic forces? What the hell? Those things are reentry rated. Oh, well, that's good. That's excellent. Alright. Whoa. Dude, come on. Okay. This is a bad omen. What are we at? 26 kilometers? I did not pay attention for far too long. Alright, well, we got, what, 1,400 meters per second in our main engine? Yeah. Oh! Okay, light it up. Did we lose the top half of the Aero shell? How? Okay, well, this is the worst test ever. I agree with you wholeheartedly, Wookie. That should not be happening. Oh god, we lost our primary parachutes, too. How the hell did this happen? Hold on a second. Wing spaceplane, aerodynamic stresses, joint between interstage stresses, joint stresses. Stresses on the wing structure. Wing structure, wing structure, wing structure. Cubic octagonal strut collided into wing. Great. You mean wing collided into octagonal strut? Collided into procedural wing? Yeah, all of our parachutes are gone. Well, this has turned into the absolute worst simulation ever. We're just going to go ahead and burn through this last 900 meters per second. This is insanely dumb. I guess I should check the wing strength multiplier on these things just to make sure. I think this one probably broke on this section and took out everything behind it. This makes no damn sense whatsoever. What do we got? 13 kilometers? Yeah, better to know now. Not even going that fast for stock KSP. Yeah. Whoa. Hello. Shutting down. We got 1 meter per second. If we can just terminate this spin. Come on, get to retrograde, buddy. We gotta ditch this thing. Alright. Get rid of it. Get rid of it. Light them up. Vapor and feed lines. Well, at least those wings got... Never mind. Well. Landing just got a whole lot easier, everybody. We ditched the cargo. Hey, we're up to 5 kilometers per second of runtime on this, TWR 1.6. This just got so much easier. All you have to do is kill your Kerbal. I have no idea what happened. What channel do you put music in? Whatever one you want, I guess. I mean, we're just going to go ahead and let this hit the dirt, because I don't even think we can save it at this point. Press H. Smush. Press escape. Almost Shugazi music just started. Better to know now, yeah. Definitely. Your phone crashed because Dell updates stuff right when stuff started exploding. Some structural failures. Some collisions due to said structural failures. And then everything just went badly. So we would get back into the VAB and just double check the strength multipliers on all of our wing segments. All of them should be at the default of 1 because it's something I very, very rarely change unless I'm really, really, really trying to get skinny with the weight. So yeah, they were all there and everything was fine. What I did figure I'd go ahead and add is the second set of reaction control thrusters to the top module. Because, well, they were always needed, but weren't quite present. So we just go ahead and get that setup figured out and do a little bit of dialing in here with things, although it looks a little awkward. And for some reason, the copy on the move didn't translate very well, which is creating some very, very weird artifacting, which also caused me to get just a little frustrated. But here's a much better look at our lab crawler from all angles. The big docking port at the back is how it attached to its descent frame. The 4 little descent engines. It is independently powered, both through a solar array and through 4 RTGs. They're planted on the side, which will also help keep our astronauts warm. We're going to try to lighten this load a little bit. I would like to get each of these down to about 100 tons so that we could fly them on the much cheaper DN series rocket instead of having to use the big boy BPR to get them to Mars, which would save us a whole lot of money. As you can see, we don't really have a whole lot, and after wasting close to $100 grand on fruitless simulations so far. I think it would be a excellent idea to try to put these on a much cheaper launch vehicle. But yeah, I've already screwed up enough with those thrusters, and so we're not going to save this design. We're just going to go ahead and move on to testing the supply crawler, which I was actually far enough along to do entry testing with, thus the big heat shield, which I don't think is going to stay. Although the wing segment stressing does have me concerned, because that has not happened on any other testing, including Earthbound Reentry, just using a heat shield large enough to cover the engine segment. So we will we'll have to see how well all of this works out. So the new and interesting problem that we're having here is that suddenly our control module is flipped. Up is no longer through the parachute, but down through the engine. So we have to fire prograde to make our deorbit burn. And really not wanting to waste yet another simulation, we'll just go ahead and say that down is now up and up is now down, and we're just going to go ahead and go for broke and try to get this thing down through the atmosphere and have just at least one successful test today. That's all I really wanted. The physics warp wobbles, ever-present as they are, not really concerning. I've seen all of these in all of my previous testing, and as long as we maintain a solid angle above horizon for the good part of our descent, we should be okay, although our vertical speed is not sinking nearly as much as it should be, considering our altitude and speed, which is likely a facet of me not paying nearly enough attention to things as I should have been. But when we do get our pitch angle up to about 50 degrees, we do see that sink rate start to drastically fall. We've already shed 5 meters per second in just this sentence about it. So I do know that these things can bleed off speed fairly well. I just need to be more vigilant about maintaining that angle and kind of loosening up on those wiggles a little bit, which means for the actual landing events that are not simulated ones, I will probably have to do them in real time, which is going to take an insanely long amount of time. But you see our vertical sink rate now slipping below 40 meters per second, even though our angle is not quite as good as we would like it to be. But as we're coming down here to about the 40 some odd kilometer mark, we can start to really lean in and focus more on bleeding off speed than maintaining altitude. Again, that 1400 meters per second will not all be available to us, but whatever we can use to help slow ourselves down, we will absolutely take. So we're just going to go ahead and let that vertical speed creep up so we can get into thicker parts of the atmosphere in preparation of our final braking bird, which is supposed to help ease us into parachute deployment so that we don't, shred everything. But I think I actually have a contingency worked out for if we do. There's 2 sets of parachutes there, a primary and a secondary, so we can lose one and still be all right. But for the rest of this landing, I'm going to turn you over to old me. So, starting to see some serious drag now, but our sink rate is really picking up. So, let's just go ahead and lock this to prograde. It's not really worth fighting it anymore. Of course, physics warp fights everything, because nothing likes to stay the same. 23, 22, 21. Just sink into it. 20 kilometers. Mark. Ignition. We'll just go ahead and burn this off and see if we can't buy ourselves a cheap, easy, free landing. Does Principia have automated orbit station keeping system yet? Be wicked easy, or wicked cool if it did. Make things a lot more tolerable, I guess is the word I'm looking for. This parachute, is not armed. Good. Good. I thought I hit arm mains. Apparently I did not. When is that parachute supposed to deploy? Soon? Nowish? Arm? Well, we're certainly slow enough for it to deploy. We'll go ahead and kill that, let ourselves fall. Now that we're going real slow, this is cheater mode activated. There's some parachutes. Huzzah! Alright, so we're just going to go ahead and ditch our lower stage. Come on, man, really? There we go. Please don't come back to bite us. Oof. And there it is. If you could... What the hell? Yeah, I guess we're still, we're coming into enough Aero forces now to where things are getting weird because we're going real slow. We should not normally be going this slow. There is full deploy. That should have snapped us onto our retrograde vector, which is actually our prograde vector because something is upside down. This is not going well either. 4 kilometers, great. Come on, snap to it, friend. Snap to it. There it is. Yes! The spin, though. I don't understand where that came from, but whatever, we're just going to deal with it. You could just zero this out for me. Down to 1.5 kilometers, 23 meters per second. The spinning. There's our upper half of our aero shell. Those chutes are going to auto-cut at about a kilometer altitude. So the spin really does look like it's being induced. Why is that thing falling like that? I mean, seriously. What the hell? 900 meters. Those parachutes should have cut by now, because we are under a kilometer of altitude. That is definitely under a kilometer of altitude. I'm sorry, chat. I will check on you in a bit. This is getting a little nauseating to watch, and I'm wondering why the hell it's happening. Because this did not happen in any of my previous tests. How are we speeding up? Oh, because we're off axis. Come on, man. One successful test, my asshole. Base to prograde. One successful test, my asshole. How does this even become a thing? I am so confused. Huh! Most of it survived. One half of the supply pod, but none of the solar panels. Oh, dude. Our Kerbal made it. Jesus, Jaeger. You lucky fucker. Nope. Not in the right place, and no engineer for which to fix it. Well, we were actually able to eventually work this rover right side up by a very careful and planned articulation of the solar array arm, which completely lacks solar arrays, before tucking it back into its storage position, and then just kind of demonstrating how this rover drives around, which pretty well, I'd say, despite the intense debris field here. But we'll get a better look at this thing back in the VAB here in a little bit, after a very interesting and highly bugged landing, I think. You see, here in the VAB, all of our delta V is actually not negative, indicating that the control core should be facing the correct direction. There it is, but just to make sure, we'll switch it. and then reattach everything. Yeah, numbers there still not negative, so I guess Mech Jeb doesn't really account for that. But if that was the error, hopefully it should be rectified by now. And just a quick check through RCS build aid for our engine thrust. There should be nothing here that is causing that much of a spiral during descent. It just seems incredibly odd that all of that would just suddenly befall us live on stream. KSP never change, never change. So the supply rover, I should say, is responsible mostly for life support supplies, although it does also carry scientific equipment in that KIS 2.5 meter bay, which is enough to set up a couple of remote drop science radio in stations, or at least one or two at the base itself, so that we can actually have some things to research while we're sitting on the surface of Mars. 2 of these are intended for a single deployment of a crew to the surface station, and of course, as needed, we can hopefully fly in more to keep the crew fed and breathing during what I hope to be extended deployments to the Martian surface over the next couple of years. We do remain hopeful that we can actually have a successful landing on Mars with a crew sometime before this decade is out, is my personal goal, and I really hope that these key components of our M97 plan can bring this all together, and we can see a long-term scientific mission on the surface of Mars before we get into the year 2000, which is, I guess, the whole goal of this program. So I will get more into how this base and all of its pieces fit together now that we've kind of covered how bad my landing plan is, but we will be working on that more in the future. So expect more from this segment of the program in coming episodes. But for now, that's going to do it for this one, everyone. Thank you so much for hanging out. I really do appreciate it. And I will see all of you in the next one. So until then, see you later.